Hello, and welcome to a demonstration of the Jeliot program animation system developed by the University of Joensuu in Finland and the Weizmann Institute of Science in Israel. Jeliot automatically animates programs in Java and is intended for use in teaching concepts of elementary programming. Let us start by opening a Java source file. The program is displayed in the left pane. It is an ordinary Java program for computing the maximum of 3 integer values and might be used to teach the concept of nested if statements. Preparing the animation requires no effort on the part of the user. Simply select the Compile button in the lower left of the frame. You will see a curtain open in the right pane called the theater. There are 4 familiar buttons that control the animation: step, play, pause, and rewind, as well as a slider to select the animation speed. I'll increase the speed a bit and play the animation so that you can get an overview before we study the animation in detail. Note that the theater is divided into 4 areas. The top left area, called the method area, displays the stack of activation records. The top right area, called the expression evaluation area, displays the computations and messages related to control flow of the program. The bottom left area, called the constant area, is used for constants, including literals, and for static objects. Finally, the bottom right area, called the instance and array area, represents the heap used to store objects. Let us now rewind the program and step through it. Select step repeatedly and watch how the activation record for the main method is created, together with the local variables that are initialized. The literal initial values are assigned from the constant store. Next, the first if statement is executed, beginning with the evaluation of the expression I is less than j. Since the result is false, an annotation is displayed choosing else branch, and the source code of the else branch is highlighted. Research has shown that these animations facilitate the understanding of control statements by novices. The nested if statement is now executed by evaluating I is less than k. The else branch is chosen again, and the print statement is executed. A hand animates the transfer of the value of I to the console display at the bottom right of the frame. Suppose now that a student asks how the program works when the largest value is the second one. All we have to do is to select Edit, modify the program, and animate again. Since the animation is generated automatically and on the fly, it can be used in lectures and labs to explore issues as they arise. Let us rewind the program once again to demonstrate important features of Jeliot. Open the Options menu and ensure that Show History View is checked. We select Run Until to skip over the initialization of the program that our students understand by now. Suppose that we step until the second if statement is reached, and we wish to recall how execution reached that point. We select the History tab, and then we can step backwards and forwards through frames of the animation in order to examine it more carefully. The next example demonstrates the use of Jeliot when studying concepts of object-oriented programming in Java. The class song is intended for use in an online music store. The fields of each song are its title, its length in seconds, and the price per second of the song. The class contains a constructor that initializes all 3 fields, and a method that computes the price of a song by multiplying its length and the price per second. Step until the constructor is about to be executed. Constructors are very difficult to learn because a single line of code causes many actions to be carried out when it is executed. With Jeliot, it is easy to follow them one by one. The variable of type song is allocated in the activation record and initialized with the default value null. The constructor is called with 3 arguments of the correct types. An object is allocated on the heap and its fields initialized with the default values null and 0. The constructor method is called and the values of the arguments used to initialize the values of the parameters of the methods. The statements of the constructor method are executed. They copy the values of the parameters to the fields of the objects. A reference to the object is returned and assigned to the variable song. Next we see how a method is called on an object. The reference to the object is an implicit argument of the call and is assigned to the this variable within the method. This enables the method to access the fields of the object. Finally, a double value is computed and returned to the main method. Let us end with a quick look at the Jeliot website at cs.yoansu.fi/Jeliot. Jeliot can be downloaded in several ways: Java Web Start, a Windows executable installation, or as a portable jar file. Jeliot can also be executed as a plug-in to the BlueJ environment. This gives you the best of 2 worlds: the class diagrams and interactive execution of BlueJ and the dynamic animations of Jeliot. A link is given to a set of learning objects for concepts in Java. By using the automatic animations of Jeliot, learning objects can be developed without the effort required to use multimedia tools. The publications link directs you to a large number of publications on Jeliot covering design, pedagogical research, and extensions to the basic software. Thank you for watching this demonstration. We hope that you will come to feel, as we do, that Jeliot has the potential to significantly improve learning of elementary programming.